Hey everybody, this is Christian and today I will show you how I'm automating my home lab with GitLab CI CD. This is absolutely amazing because it allows me to streamline all of my workflows in fully automated pipelines so I can sit back and relax while it's doing things like deploying Docker Compose and Kubernetes projects for me or configuring and provisioning infrastructure using Terraform. It's like magic and the possibilities for using it are really endless. But I want to make this clear, this is not just about saving time and being more convenient when managing your personal projects. No, this is also a great chance to learn more about continuous integration, delivery and deployment, or what we shortly call CI CD. This is nowadays a super important topic to know in IT because it helps us to build and ship applications faster, more securely and reliably. With GitLab CI CD, you can easily learn and implement this technique completely for free in your own self-hosted environment. It's not just cool, it's empowering. So let me show you how I'm doing this in my home lab and hopefully inspire you to use it in your projects as well. But before we start, I quickly like to show you another incredible platform that I recently tested in my home lab called CheckMK, the sponsor of today's video. CheckMK is a comprehensive IT monitoring platform that is scalable, automated and highly extensible. With over 2000 GPL v2 licensed plugins, CheckMK can monitor nearly all network components across different manufacturers. You can even write custom plugins to monitor anything you want. It offers auto discovery with pre-configured thresholds and rules, and the features are insane. It is massively scalable to monitor hundreds of thousands of hosts and millions of devices, and furthermore, it creates stunning visualizations and has dynamic dashboards with logs and event monitoring that allow you to really drill in all of the details of your infrastructure. Of course, it also notifies you about anything that requires your attention. And the cool thing is, they even have a free and open source version that you can easily self-host in your IT environment. Of course, for professional companies, they also have enterprise, cloud and MSP versions that even come with more features. But I recently deployed the free and open source version in my home lab to monitor the health and status of my Proxmox hosts, VMs, Docker containers and even my firewall using SNMP. Just to let you know, I'm planning a full dedicated tutorial on CheckMK as well. But if you'd like to try it out yourself, check out the official website and get started today. Of course, I'll put your link to it in the description box down below. Alright, so now let's get back to CI CD. And first of all, let me introduce the concept. So what does CI CD actually mean? What are the typical components and what solutions exist so we can understand how GitLab fits into this bigger picture? The first part of CI CD stands for continuous integration, an agile software development practice that runs automated builds and tests against code changes to help detect integration issues early in the software development lifecycle. This is really important, primarily when many developers work on a single project and merge their work into a shared repository, because one developer might not necessarily know what the others are doing, and without a proper validation process of the code base, any new changes might introduce conflicts with existing parts of the code. Or maybe another use case is you want your code changes to automatically be checked for programmatic or stylistic errors before merging. This is also called linting in software development. And this is super helpful because I bet you all know these situations where you're just missing a semicolon somewhere in the code or you have a wrong indent level in Python. It's really a pain to find these type of issues in your code that's causing everything to break. And by using an automated validation process that runs every time you push changes to the repository, this is really great to detect bugs early and ultimately improve the overall quality of your code. So that's it about CI, but in addition to that, we also have CD, which stands for continuous deployment or continuous delivery. Actually, before anyone wants me to correct in the comments, I know deployment and delivery are two separate processes, but they are often most used together. So for simplicity, I think you can see this as just one step that streamlines the deployment process of your code. So in reality, this means once a new change is tested and verified by the CI automation, the CD automation can immediately deploy this on the infrastructure without someone having to manually log into a service, download the new version from the repository and apply the changes manually, which not only reduces the likelihood of mistakes, but it also enhances efficiency in the deployment process, of course. So this whole CI CD concept is an essential part of DevOps, and over time, many different tools and applications have been created with very unique features and integrations to help organizations implement these CI CD practices. For example, Jenkins is a pretty popular solution that is designed to handle anything from a simple CI server to a complete CD hub, or Argo CD, a continuous delivery tool designed specifically just for Kubernetes applications. I've also tested this on the channel in the past, by the way. But of course, big Git platforms like GitHub, GitLab, or even Git have built their own integrations and solutions for CI CD directly into their platforms. And the cool thing about GitLab CI CD in this case is that it is completely available in all of the tiers. So from free to premium and ultimate, and it can be used in any offering, like it runs on their GitLab.com cloud platform, as well as on the self-managed devices, which I think is really great for privacy and local deployments in protected networks. And it is super simple to use because you don't need to install any third-party program or tool. You can just use this in all of your existing GitLab repositories. And by the way, if you want to know how to deploy such a self-hosted GitLab instance in your own home lab environment, I've made a full tutorial about this. Of course, you will find a link to it in the description, so check that out. And all you have to do to simply enable GitLab CI CD in all of your projects is create a .gitlab-ci.yaml file where you can add all of your instructions and settings, and then find or create some GitLab runners for your projects. Now that's the next concept I have to explain. What the hell is a runner? Well, runners are simply agents that executes the task that you have defined in the CI CD pipeline. So this is where the code validation, the testing, or the deployment process are actually running on. And a runner can be anything from a simple Linux, Windows, or Mac OS machine to a virtual machine running on a hypervisor like Proxmox, or you can even deploy a GitLab runner in a Docker container. So the way how you deploy this GitLab runner is completely up to you. You can even deploy a fleet of different GitLab runners, as many as you need, which is really important because some of the programs or automation pipelines that you want to run won't work on every environment and every operating system or technology, of course. I just give you a very basic example. When you want to build a Docker container image automatically from your source code in the Git repository, that doesn't really work so great when the runner itself is also running in the Docker container. So this is also called Docker in Docker, and it really doesn't have a great performance and so on. So that's where you might want to install a separate runner just for building Docker images and install this on a virtual machine. Or if you're going to build container images for the ARM infrastructure, it doesn't work so well on an x86 architecture. So you might run another GitLab runner on a Raspberry Pi, for example, for faster building ARM images. So these are some usual type of workflows where you might want to control multiple runners and use tags in your automation pipelines to specifically use that infrastructure that you need for this automation pipeline. But we will go through the pipelines in a second here. Just to simplify this tutorial, I will only show you how to deploy a GitLab runner in a Docker Compose project. That's what I'm using in my home lab as well. But just keep in mind that it doesn't necessarily have to be the preferred deployment for everything, and there are different possibilities on how you can set up a GitLab runner. Adjust that depending on the environment that you want to use it for. Alright, so let's go to my self-hosted GitLab platform and let's create a new runner so that you can follow the process. This can be done in 3 different levels. You can use a runner just for one Git repository. You can add a runner that is available in a group. So this runner can then be used throughout all of the repositories attached to this group. But you can also create instance runners, so they are available across the entire GitLab instance. So that's what I personally would recommend you to do, because then you can use the runner throughout all of the projects and groups that you have created. So let's go to the administration interface and go to CI CD. Here in the runner section, you can register and create new runners. It's very simple. You just click on new instance runner, and then you can give this runner specific tags. So again, the tags can be used in the automation pipeline to define which runner to use for what type of task. If you don't want to use tags and you just use this runner for all of your jobs, you can also click on run untagged jobs. There are also some other optional configurations if you only want to use that runner in protected branches only, but usually you don't need to configure anything else here, just click on Create Runner. Now you can choose where you want to install this. If you want to install this on Linux, Mac or Windows, Google Cloud, or maybe you want to use containers like Docker or Kubernetes. So below you find instructions on how to do that. But of course, you probably know I've created a boilerplate for adding a new GitLab runner using Docker Compose. So therefore, I just go to my Git repository. So here I'm collecting all of the Docker Compose templates for all of my videos and projects. And here you should see a new folder that is called GitLab Runner. So let's open a new terminal connection to one of my test servers here and create a new directory called GitLab Runner. Let's cd into this and open it in VS Code. Let's go into the project directory and let's create the compose.yaml file. And I also want to create a config directory for the config file. So let's also grab that here. That is written in TOML, by the way. So I think now we should go through some of the configuration settings in here. First, let's start with the Docker Compose file. So that's very simple. It just deploys the latest image of the Alpine GitLab runner. I also want to give it a container name. Just call it GitLab runner 1. I think that's fine. And then, of course, we need to mount the config.toml file into the containers file system where the runner process can find it. And what we also need to do is we need to pass in the Docker socket. So you might wonder, why the heck do we need the Docker socket? Well, the process is how it runs. The GitLab runner itself will run in a Docker container, but if you start a new automation process, it will spawn a new Docker container with a temporary process where all of the automation steps are running, and then afterward it deletes it. So this is done by the configuration setting here in the config file, executor Docker. So there are different types of executors. Again, I will only show you this example here. Of course, when you have automation pipelines that invoke specific processes like shell scripts and so on, you might not need to run them in a separate Docker container. But I think this is really great because for these automation pipelines, you might want ephemeral processes. And this is where Docker containers are just the best for. This is why I'm using the Docker executor to spawn a new temporary process, executing all of the steps that I need, and then exit. You can, by the way, also define an image for this temporary Docker container that should be created. By default, I have added the Docker latest image because that already comes with some of the tools you might need for Docker automations. However, you can also define a custom Docker image that the runner process should create. And there you can install and provision this image with your custom tools. For example, if you want to build an automation pipeline that requires a specific program or library, you can create a custom Docker image, include this, and then you have all your tools and your libraries and processes already in the temporary process where the automation pipeline needs to execute them. However, I will also later show you can also define other images by process. So that's what we're going to take a look later. This is just the default configuration if you don't specify an image. The one and only thing that we need here is before we start the container, of course, it needs some form of authorization and it needs to know where the GitLab instance is running. So that's what you need to change here. So change the gitlab.example.com. So in my example, you can see I'm running this on git.home.ccrave.de. So I'm going to copy this, paste it in here. And we also need to add the registration token here. So that's important for the authentication to the GitLab platform. And the registration token you will find in here when you register the runner and created it. It will show it here, the runner authentication token. So let's copy this, paste it in here. And yeah, I think that's all fine. So we don't need anything else. We can just start up the process. So let's go to my test service. So here we have all the files and let's start the container. Now it's pulling down the GitLab runner image and start the process. And once this is finished, we can go back to the GitLab platform and click on View Runners. So here we should see a new entry, as you can see here. Below here, this is my production runner. So this is the runner that I'm using for all of the automation pipelines. I should probably define some tags for it. Otherwise, I might not know which runner the automation pipeline will start on. So let's create a tag for testing, for example. Yeah, I think that's fine. All right, so now that we have deployed our GitLab runner, we can start writing the GitLab CI YAML file. Again, you must place this in the GitLab repository where you want to use it for. So for example, if I go back to my projects here, I've created a simple test project that we can use, GitLab CI test Docker. So this is a repository where I have added a Docker compose file for an Nginx server and also a simple test script. And let's clone this to my local machine. Of course, we want to CD into that and open it in VS Code. So then in this repository here, we can simply create the .gitlab.ci.yaml file. So make sure to not call this YAML with JAML, just JML. Otherwise, GitLab will, I think, not recognize it. So that's important. And now, of course, there is a specific format or a specific way how you structure your automation pipelines. Because a GitLab pipeline always consists of jobs. So these execute commands, compiling, testing, deploying code, and stages. And the stages define how to group these jobs together. So this is a way of organizing and managing sequences of jobs. By defining stages, you can logically group related tasks and control the execution order. For example, if you have a testing stage that tests and verifies your code, then you have a next stage for building the code and a third stage for deploying the code to cover all of the processes of CI CD. So let's try to simulate something very, very simple to get started with. So the format of a GitLab CI file is actually pretty simple. It's in the YAML format. So you just define the stages, and you can see here the AI already suggests something. I would not use build, but maybe let's call it test for now. And yeah, maybe let's also add different stages for building and deploying. So that's what we're going to use later. And now you can just start defining the jobs. And these jobs are basically defined in key value pairs, where the key is the name of the job and the value is a YAML object that contains configuration details. So here in the documentation, you find some examples on how that would look like. You always need a script. So these are the commands that are executed by the GitLab runner executor, which can contain a shell script or simple terminal commands. Yeah, it's up to you. And let's create another test script job. So this will just execute the test script here in the scripts folder. So first define with the name of the job and then define the stage where this should be running. So in the first stage, testing here. And then we define a script command. So I will execute the sh command and in the current folder. So this job always starts with the artifacts of the Git repository, of course. So you can just refer to the directory where the script is located in test.sh. One thing I want to do here is, because I just told you we have defined different runners here on my instance. So we have a production and a testing runner defined by tags. We should define that this is running on a runner that has a testing tag. So let's go back in here and add another section called tags. And here you can define testing tag. Okay, so that's fine. All right, so what will happen when I push it to the Git repository? By default, these automation pipelines will always run when you push or merge code. There are rules where you can define, so only when you merge or push code to a specific branch, this specific script should run, that you can define in the so-called rules, but we will cover this later. First of all, I just want to have this script to be always executed when I push or merge a change into any branch of the repository. So currently we are in the main branch, but we could also be located in a different branch. So let's do this and let's commit the changes here. So I'm using VS Code, or should I do it in the terminal if that's simpler for you to follow? I don't know, but maybe let's do it in the terminal for now. So here you can see the Git status has changed. We have some untracked files. So we added a new file in this Git repository. So let's add this file. We have new changes that want to be committed. So we commit the change with, for example, adding CI CD testing. And once we committed it, we push it to the Git repository. So most of the time, I'm just working with the VS Code UI because it's doing all of these commands in the background. But I think sometimes it's useful to show the actual process, what is happening. And now, because we have created this CI file and it should be triggered, we can go back to the specific Git repository here. And let's go in the section Build Pipelines. So here you can see it's running a new process. And while it's currently running, you can see when you click on this, the different stages of your job. So if you would have more stages, they would add up here. And because we only defined one testing stage or one job is just running in the testing stage, you can see there's only one entry here. So when we click on this, you can also see the logs. You can see it already succeeded and it executed the whole stuff. So I just want to show you one more thing. If we go back to the virtual machine where this Docker container is running, you can see that the GitLab runner is still running. So this hasn't been changed. But when we do a Docker PSO, maybe this has already been deleted. So unfortunately, but while this process is running, you can see a new temporary Docker container that the GitLab runner will start with the Docker executor. It has a temporary name, and this is exactly where these commands that you see in the log here are executed on. And then it's just executing everything that I've defined in the pipeline. So here you can see it initializes the Git repository. It first automatically always clones the Git repository that it's running on. And then it executed this here, the shell script that we have defined here under the script commands. And when you take a look at this script for a second, you can see it's echoing running tests. And then it's just printing some current information about the OS and the environment it's running in. And then just exits. If you take a look at the logs, you can see that is using Alpine Linux. And then you can see some information that has been, and then you can see the output of the informational commands that have been executed in here. So I think this is very simple to demonstrate how it will work. So of course, you can extend the script and do some stuff like, I don't know, building software, pushing software to a container registry, or whatever you want to do with it. But I also want to show you, of course, some practical use cases, because just invoking a test script, okay, so this is like a hello world, so to speak, but it doesn't teach you anything on how you can use it. So I thought, let's do some practical stuff with it, because we have a compose file in this project here that will spawn a new Nginx container, And it has a config file, an Nginx config, and an HTML content like test website. And maybe we want to use GitLab CI to automatically deploy this compose project to one of my testing servers so that I don't need to take care of logging into the server, pulling down the latest version from the updated repository and deploying this. Because one of the processes that I really often use is I usually don't use the latest image tags. I have a specific version of the image that I want to use. And whenever my Git repository updates with the new image version, the natural process is that I would have to log into my testing server, pull down the latest image, and restart the container with the new image. And I'm using GitLab CI to automate this deployment for me. So let's try to replicate this with this test project here and deploy the Nginx compose project on my testing server. All right, so what we need to do is we can just leave the test script stage in here. I think it's not going to hurt us. But in a new deployment stage, we will define a new command. So what we need for this, we need a little more preparation here because this is just invoking a simple test script. But of course, if we want to do something useful and deploy a Docker container, we have to copy the files like the configuration, the website, and also the compose project itself to my testing Linux server. So that means the automation pipeline needs to somehow authenticate to this test server. And this is where we need to store some secrets or some variables into the runner processes. So this is a really common process. You will often have to do that. And just like you can imagine, there is a feature in GitLab CI CD that handles this type of variable thing called variables. Really simple. So you can predefine CI CD variables just in the job in plain text here. So when you add variable section to the jobs, but of course that would mean that you have to have these things in clear text in your deployment files, and this is never a good idea. So especially when you are dealing with secrets or credentials, there's a better way how you can do this. And that's defining these things in the UI. So let's go back to the Git project. You can define variables on all of the 3 different levels. You can have variables defining on the instance, on the group, and also on the Git repository. So that might be useful if you have a shared credential secret that you want to use across the entire GitLab group, so all of the repositories there. Then you don't have to manage these credentials for each Git repository. But in this example, I just want to create it in the testing repository. So let's go to settings, let's go to CI CD. And here we have a section called variables. As you can see, I've already created a secret that contains my private SSH key that I can use to authenticate to my Linux machines. If you want to add such a variable, you can just click on Add Variable here, define the visibility level, if this is a variable you can see in the jobs logs, or it's a masked or hidden variable. So masked and hidden, or just masked, this is useful for credentials like API tokens and stuff. Unfortunately, what does not work is the white spaces in the SSH key. So I don't know if you can somehow convert it or so, but I just used the visibility level visible for my SSH key, which is honestly not a good idea, but that's the only way it works for me. What you definitely need to disable here is the protected variable, because otherwise the variable can only run in protected branches and tags only. And if you want to use it in an unprotected branch, you have to disable it. And then you just add your key here, for example, SSH key, and then put the value of the private SSH key in here and add the variable. So that's how I got that one. And then you can use this variable across the entire GitLab automation pipeline, and you never need to define it somewhere here in clear text. Let's start creating a new pipeline for deploying the Nginx container. I will just call it deploy Nginx. Yeah, okay, yeah, let's go with that. Yeah, the stage is deploy, so that's already correct. And then I will first start with the script command. So here I would create a new command that copies everything onto a remote server. Of course, you can have any other process that you like, but I usually do it like this here. So what I need to do is I will use some other variables so that I can reuse them, because you can also define them in here. But this is not for secrets. For example, if I want to define the remote host, so this is server test1 from let's see crave.de, remote user, remote path. So this is a path where I want to copy the files, and I want to just copy it in my local directory Nginx test1. So this is like I put all of my Docker Compose projects in my users folder. I don't know if that's the best way to do it, but yeah, that's just like how I do it. And now we can use these variables here as well as a secret. So what we will do here, I will replace this with remote user and remote host. And first of all, before we deploy the container, we of course need to copy it somewhere. And we want to make sure that this directory is existing. We want to create the remote path on the remote server. All right, and then you just define the next command. Next, we want to copy it using SCP. I think the suggestions from my local AI server are pretty good here, so we can just use it. By the way, if you want to know how I've built this AI server, then check out my other videos. And yeah, I will also make a short video showing you how to connect it to VS Code. Let's first copy everything from the deployments. Yeah, deployments Nginx test1. So this is the directory where all of the stuff that I need is located in test1. So everything onto the remote server, remote hosts, and then in the remote path. Okay, so the next thing is, so once we have copied the files, we want to execute the Docker Compose up command. That's all we have to do, right? So we can simply just execute this here, remote user, remote host, Docker up, and force a recreate. So maybe we can first of all pull the latest version to make sure if I update the container image that it's pulling down the latest version. Okay, so before we can run this, of course, we need a few other things to be present here. First of all, we have the SSH key that we have defined in the variables here, and we need that SSH key so that the runner can successfully authenticate with SSH to the server. And if you want to make sure that there are some commands that are always executed before the script commands, there is something that you can define here before script. And then you can add some commands that maybe install some packages. For example, what I found out is that if some of the Docker images that spawn the temporary runner process, they don't have the OpenSSH client. So we can use an APK add. Also curl might be useful in OpenSSH so that these tools are automatically installed in the Docker process of Alpine. And then, yeah, we don't need the Docker package in here. So that's not a good suggestion. But what we will do is we will echo the SSH key and put it into ID RSA and also make sure it has the right privileges. Otherwise, we will also get an error. Add this to the SSH agent so that the script commands later have the correct authentication credentials. Let me just check if this is working. Sometimes there are things that can go wrong here, but let me just test if that's working. So let's return here, git add the changes, and push this. And this should invoke a new runner process. So let's go back to the project, and let's go to build pipelines. And oh yeah, just like I thought it would fail. It's always the case, but well, it doesn't matter. So you can see it now executed 2 stages here because we have defined 2 stages, test script and deploy Nginx. And the first one has been succeeded, right? You can see it here. The second one failed. So we can click on that and go through the logs and see why it has failed. So we can just follow the execution path. We see it installed the OpenSSH client correctly. It outputted the SSH key and invoked the first command here, but you can see Docker compose not. Okay. Again, this is an error that has been created by AI. So if you're lazy and you trust AI with your stuff, it's never gonna work flawless, right? So you can see here it's using the old Docker compose syntax. It's not using the newer modern Docker compose syntax without the dash. So thank you, DeepSeek or Quencoder, whatever I'm using here. Just going to push the changes here in the VS Code UI. So this will literally do everything that I've done here in the terminal, just in the background. We can just go back to pipelines. And yeah, let's go in here. So here you can see it's second one is also failing here. Okay, so but yeah, you have to walk your way through it. No configuration file provided. Okay, I probably should have added the command to cd into the correct directory, because otherwise it will just execute it in the current directory, and that's not working. So what we need to do here is we need to add a -f and define the remote path so that it will execute and these on the compose.yaml file in the nginx-1 folder, so where I have copied the project, of course. Yeah. All right, let's do another one. All right, so that has been successful. Now you can see that it's executing the command in the correct remote path on the compose.yaml file. It's pulling down the nginx image, and then afterwards it's starting the project, and nginx test has been created. Okay, so maybe we should check on my remote server if that's really the case. So you can see that's the nginx container my GitLab runner has automatically created for us. So if we go in the project directory, the project directory should be located in here. There you can see, yep, it just copied it. And it also has, hopefully it has all the files in it. And yeah, you can see the config and the HTML file. So I think we can also test if the server is running. So let's see. And yep, we got back test page. All right. So that is how you deploy a simple Nginx web server using automation pipelines, GitLab CI. That's pretty cool. Okay, so I know this might be enough for a simple demonstration, but I just want to show you a couple of more stuff. So how I'm using this in a practical way in my home lab. Because so if I go back to my Git projects, you can see I've created projects for every type of service or application that's running in my home lab. By the way, in 1 or 2 weeks, I will do a full home lab tour. So don't worry, there is something coming where I will go through all of the stuff that's running my home lab and how exactly I'm running it and why I'm running it and so on. I just want to show you one example here, for example, the homepage container. So here I have a deployment. That is my home lab dashboard. And whenever that gets updated, I am creating an automation pipeline so that automatically checks my compose file if there are any errors or something like this. And then there's also a deployment pipeline. So this is very similar to what we've just done. Yeah, it copies everything from the Git repository onto my remote server and then pulls down the latest container image, takes the old image down and starts it again. And one thing I wanted to show you here are the rules. So with rules, you can add something like if-else statements. For example, how I'm using this is that I only execute this deploy command if the commit branch is main. So when I'm doing some testing or I push it to a testing branch, this, of course, should not deploy it on my production infrastructure. It should only deploy it to production when I push or commit something to the main branch. Right? And that's how I change the rules. And what I also found out, sometimes I have multiple deployments defined in a Git repository, and I only want to run the deployment when something changes in that specific compose file. This is how you can also define it in the rules. You can say if the commit branch is main, and the commit changes this compose file, only then the changes have to be applied to the infrastructure. And the same, I'm doing it for the home lab configuration. So if anything in the config folder changes, this automation pipeline will copy the new configuration to the remote server. So what I can do is I never need to log into my remote Linux machine. I can just change the stuff in the Git repository, and then it's automatically checked and verified and deployed. But I also have done other cool things. So, for example, if you go to Home Lab here and let's go to DNS, for example. DNS is a cool example here because, as you might know from my previous videos, I'm managing all my DNS entries in a Terraform file. So here in the record set, you can see the DNS entries for my Proxmox server or for my NAS, for my switch, for my Kubernetes deployments, for my servers, like for everything is defined in this file. Here in the GitLab CI, you can see the process here. So here I am adding the secret variables for the Terraform project and the TSIG key that I need to authenticate to the DNS server. I'm running a different container image here because I need this automation pipeline to be executed with the OpenTofu image so that it has the OpenTofu library and the commands. And then I'm simply just executing a tofu init command to initialize the backend. Again, I've explained this in my GitLab Terraform tutorial. And then I just run a tofu plan, output it to a plan, and tofu apply so that any changes in the Terraform files will automatically apply to the infrastructure. So I can just demonstrate how this works. It's pretty simple. Whenever I need a new DNS entry, I can just go in here, go to the record set, and just add a new entry here. For example, I need a new test entry for a new server that I'm deploying that is called test.home.ccreative.de, and this should be the IP address 10.20.32.45, whatever, right? So this is a change that I push to the Git repository, commit the change, and when I go back to my Git repo, so here, build pipelines, you can see there is a new automation task running that has two stages. It first tests the Terraform state file. If I made any mistakes here in the code, maybe I forgot to add an equal character here or so, then it will fail and it will not try to apply these changes. But yeah, you can see now already succeeded. So here you can see the logs. It automatically added this new DNS entry, test.home.ccreative.de. And if I just ask my DNS server, so what is the IP address for test.home.ccreative.de? You can see that's the IP address that I got. Oh, I also added another test entry before. I think this is just so cool and it saves you a lot of time. Again, if I want this to be removed, yeah, remove it. And I'm done. I don't have to take care if the DNS server is updated. The automation pipeline is doing that entirely in the background for me. So these are just a few test examples on how I'm using GitLab CI CD to automate anything in my infrastructure that is somehow tied to a Git repository. Of course, you can add many more things, adding third-party applications, adding APIs, using CI pipelines to invoke webhooks, or create a sophisticated build process for your application and code project. But I hope, as I think most of you guys probably are not directly working in software development and more working in system administration, maybe DevOps or networking, it gave you some better understanding and some practical use cases in the scope of automated service deployments or provisioning infrastructure that are more relatable to a sysadmin job or something like this. And if you're up for more content, then make sure to hit the like and subscribe button. A big thanks goes out to all of my supporters on YouTube and Patreon. So thank you guys so much. You make all these free tutorials possible. And as always, I'm going to catch you in the next one. Take care. Bye bye.